This should be a good one. This was sent over by a fellow YouTube content creator. I think most of you will know him, V Westlife, and this should be a realistic AM/FM radio that was modified with AM stereo. And I don't know if it's experimental, I don't know if it was a demo unit, I don't know what it was, but we're going to get into it here. I have not opened this yet, I just cut the tape. Okay. Enclosed is a realistic TRF radio with AM stereo modification for repair. As we discussed, I also included some documentation about the Motorola CQUAM AM stereo system and a slightly crusty engineering sample of an AM stereo decoder kit that I was given to me. Yeah, this is very well documented here. If I'm successful at fixing this radio, I have plans to ship it to an AM stereo station and hopefully get a little tour video and explanation of that station. Ooh, Smoker's Choice. I'm being trolled here. So what do we have? What the hell? Parliament Lights. Do we actually have a cassette in here? The Girl from Ipanema. Nobody can touch that song like Mrs. Miller touches that song. Okay, these have a 1/4-inch connector on them, which is pretty interesting. Okay, here's the main subject of my unboxing videos are not very good. This is our main subject, and Motorola CQUAM. So that's the stereo encoding. And it looks like we have RCA speaker outputs. Oh, look at this. Wow. Long-range TRF circuit. This is super heterodyne. Do they mean TRF like 3-gang tuning? Yeah, this is just a front end, because there's your red core. Then your blue is your front end tuned RF. So it's a super het set with a front end. Okay, well this is super cool right here. Oh God, legacy box. Oh jeez, I'm being trolled again. This is one of my favorite videos that he did. Is he sent a bunch of media off to legacy box, and then he went over how over-compressed it was and how the files weren't divided up. That's one of my favorite videos, and I think probably because we just get inundated with legacy box commercials on the radio here. They're like every other commercial break includes a legacy box commercial. So we got speakers. Well, these are interesting. These are 6x8. And they say Lowry organ. Lowry organs. Someone must have scrapped out like a console organ. I thought 6x8 was like a front end RF tube. Now, of course, the first thing I want to do is grab the cassette player and listen to this Parliament Lights cassette by Philip Morris INC, but we can do that at the very end of the video. I really want to focus on this radio, and at the end of this video, after the repair part, I want to send this over to Jim at WION 1430 AM stereo and have him test it out, do a demo of it, and talk about his station a little bit, and hopefully get his AM stereo engineer to give us a rundown on some of the technicals of AM stereo. I don't want to call it a dead format because it's coming back, which is a good thing. The reason this was sent over is for repair. Apparently it's not working right. It's deaf, poor performance, can barely hear it, and if AM stereo is anything like FM stereo, you have to start with a good solid working front end, and the front end has to be aligned right, or else your decoder is not going to work. I have all of the documentation here on the chips, so I can easily go through and we can figure out what's wrong with this. Well, let's get this radio fired up and see, you know, identify and confirm the complaint. Let's take a look at the guts here. Let's start off with this. I don't know what the voltage is, positive, negative. I'm curious about that because it looks like this comes in to a bridge rectifier and then to a 35 volt 3300 microfarad capacitor. So yeah, we need to take this board off and look at where this is connected, because this would be for alternating current. And if you wanted to feed DC into it, you wouldn't need to label a positive and negative, because the bridge rectifier would take care of that and always keep that consistent. Someone put a lot of time into this. So we have our audio output chip. We have the stereo MC13020P CQUAM demodulator chip. Then we have here, what is this, a TDA 5550. Looks like we have our stereo indicator lamp right there, which is behind the AM. And I made a mistake. I said AM FM radio at the beginning of the video. This is AM only. This is like a super remote, super fringe AM radio with the tuned front end. And it's interesting, it's got, instead of the capacitors in the tuning capacitor, it's got them separate like a Soviet radio would. So we have our RF front end, our converter, oscillator, transformer, coil, the first IF, second IF. We should have there's our germanium detector right there. And then I have a feeling this chip right here is the stock radio's you know, audio output IC, which has been replaced with this. So they're probably coming straight off of the detector into the stereo, this custom stereo demod board. Now what I'd like to do is, we need to start by pinpointing what the power supply is on this. The documentation he sent me with the chip shows 8 volts here. So that's not a standard voltage for a radio like this. This would either be usually 6 or 9 volt, and I'm gonna probably guess it was 6 volt. Someone wound around the antenna here. That might need to go away. And then they put a plug on the back. This winding might need to go away. I don't quite know what the purpose that is, except for an external antenna, but we're not going to need an external antenna for this, and that might throw the tuning of this off. I'm not sure. Let me get this board off and let's take a look at how this is wired and try and properly identify the B+ voltage that this runs on. So yes, this comes in, man, that thing looks roached. This comes in this is a bridge rectifier. Somebody really put a lot of time and effort into this. And this piece here looks like it was designed to fit over a speaker magnet in a different radio. I really wonder what this was. Look at all the tantalum capacitors on this. This was not cheap. This was not cheap to build. This was built using really good quality components. There's nothing mass manufactured about this thing. This is absolutely a work of art right here. It comes in through the bridge rectifier, filtered by this capacitor, comes down through this resistor down to a rail along the bottom that feeds, I think, the audio amp and a few other things, and it comes up through this, was this 27 ohm resistor. See, I work on tube stuff too much. These lower values are not memorized by sight. So it comes through this 27 ohm resistor, then it feeds this, then it comes over to, what is this, violet green, so what is that, 75 ohm, then it comes through a 75 ohm resistor, and then feeds this chip, and then it comes over here through 100 ohm, brown, black, brown, and on the other side of this feeds this. So I almost think that we were running 12 volts here. 12 volts. 12 volts on the bottom bar, and then maybe 8 volts on the top bar, and then 6 volts here. There are just a bunch of series resistors. There's only 3 wires connected to the top board. There's blue, which is ground, red, which goes to that 100 ohm resistor, yellow, which is going to be the signal path off of the detector, which you can see it there, comes out of the detector, and goes into, it looks like this monolithic blue capacitor right there, which is a 103, so 0.01. God, that's small. And then into the chip on, looks like pin 3. So exactly, it comes in on pin 3, and they're calling it IF, so maybe they're taking it out of the IF, and the detector is in this chip. I think the way to go about this is they want 8 volts here on the VCC, which is pin 6. So I think the way to go about doing this is to do what we need to do to get 8 volts on pin 6. Let me see where pin 6 is connected, and then we can kind of go from there as far as what the actual B+ this radio was designed to run on. You know, it would have been real easy just to write on the side of it, you know, the voltage. Pin 6 is connected to the top rail here. So if we get 8 volts at this point right here, we should have the appropriate voltages everywhere else. I have a feeling this might be the problem, is just maybe he had the wrong amount of voltage going to the radio. Let's hope, because this is too cool almost. I'd like to just see it work. It's such a thing of beauty. I grabbed a Variac and 2 power transformers here. This is a 115 to 12.6, and this is a 115 to 25.2. So I'll start with the 12 volt transformer, and we'll bring it up on the Variac until we get 8 volts on this chip. And I have the meter connected here to the chip. There's our transformer. Here we go, looking for around 8 volts. And I do have the speakers connected. Imagine that. That's what I was hoping for. It just would work. Now, this is kind of the problem with unregulated, you know, is the audio. You're using resistors, you know, as the audio bounces around, your voltage on your chips is going to bounce around as your audio load changes. So we're at 110 right there. Let's measure what the AC is going into this thing. We're right at 13.92 volts AC. So this thing wants 14 volts AC going into it. But let's see what we get if we drop it down to 12 AC. that's 12 AC. 12 AC gives us 7.39 DC on this chip. You know, these look like Zener diodes to me. And they're kind of crude regulation for something like this. See, watch what I mean by when I crank the audio up. So maybe it even wants more. Let me see if the Zener diodes start to regulate here. Yeah, it does look like the Zener diodes start to clamp at about 8.3 volts, which would help.
Our best days are behind us as a nation, not in front of us.
So, let's see what the... I'd prefer not to run the chip too far over 8, but let me see what the AC is right now. 15 volts VAC going into this. So it seems to like that. About 15 volts AC is what this radio wants.
Bendita eres entre todas las mujeres, y bendito es el fruto de tu vientre, Jesús. Santa María, Madre de Dios, ruega por nosotros pecadores, ahora y en la hora de nuestra muerte. Amén. Aquí está la esclava del Señor.
This thing is badass. Now, unfortunately, we don't have any stereo stations on the air here in LA that I'm aware of, unless K Mozart is, but I don't think so.
And now a small business setback.
Not with, no, not Blue Diamond.
Working class.
The spending bill's making progress thanks in part to West Virginia.
Somebody that's...
유행이 시작된.
Is this our favorite?
Today is a great day testing. This is only a test.
There she is. Too bad this isn't in stereo.
This is a test. This is only a test. This is only a test.
Conversation of depth and detail.
Hillary Clinton has endorsed Vance, calling her a proven leader who will bring Angelenos together to solve problems while championing women's rights and opportunities for young people. Now, her opponent, Rick Caruso, has gotten little support from establishment figures in the Democratic Party. You know, he switched to the Democratic Party to run for mayor.
So I messaged V. Westlife asking him what voltage he powered this off of, and I have a feeling the radio was just underpowered. Probably he fed it 8 volts, and I cannot blame him for undervolting it. You would always want to err on the side, if you didn't know, of feeding it a lower voltage than feeding it a higher voltage and popping it. This is obviously a 6-volt radio stock, so you would never, it would not be intuitive to want to feed a 6-volt radio 15 volts alternating current. The modification, of course, takes care of that and changes that. But yeah, I could not hold it against him if the problem was undervolting it. With 15 volts AC coming into the rectifier here, we have on the filter capacitor, we have 17.8 volts DC. That's before the series of dropping resistors. So if you were going to feed DC into this thing, remember I said that you can do that and there's no polarity here because the bridge rectifier will always correct the DC polarity that you feed in. But there would be, let's just say, a volt drop across that bridge rectifier. So you'd have to feed almost 19 volts DC into this to get your 8 volts on this chip. Measuring our DC voltage coming out of the 100 ohm resistor feeding the original radio part of the set, we have exactly 6 volts. So that's even more confirmation that 15 volts AC coming into this set is what it was designed for with this add-on. So all it would have taken was that by the original person who put this together with everything else properly labeled. I just heard back from V Westlife and he said that he tried between 8 and 12 volts DC, which is totally intuitive. When you see a radio like this, that's what you think it would run on. I don't blame him at all. It's the safe way to air out rather than, you know, feeding at a doorbell transformer and frying it. So I'm going to say that's what the problem was, is that he was just undervolting the radio and that there is no problem with this. I'm going to work on coming up with an appropriate 15 VAC transformer for this, and then I'm going to get it hopefully sent off to Jim over at WION Radio, AM stereo station, so he can demo it for us. Otherwise, I would have to drive out to Arizona to pick up Cactus Country, AM stereo, classic country. As I was editing the video, I saw a few things I'd like to point out. They are using 4 Zener diodes here to regulate the different steps. These are 1N4749, then we have 1N4744, then 1N4738. Also note how all of the resistors, see all the gold bands are all in a line, the gold bands are in a line. The resistors were installed the same way, the gold bands are in a line, the resistors, the gold bands are in a line. There are no mistakes when it comes to lining this up. This was assembled with aesthetics in mind and not using a bunch of cheesy electrolytics, but using all these tantalum capacitors, which are not cheap. There was a lot of thought given to this. These pots are not cheap pots. I almost am starting to think that this was a Motorola demo unit that Motorola made to demo Motorola CQUAM. This is something special here. A quick update, this was in fact built by Ken Steiner at Motorola around 1985, 1986. So this is in fact something very special and rare. We're going to learn a lot more about that in video part 2 when this radio visits WION. Here's what I've come up with to run the radio. 18 volts DC via these batteries gives us the 8 volts on the stereo demod chip. I have a 15 volt center tapped transformer here, so we're using one side of that, so we have 15 volts AC, which gives us the 8 volts. I have the radio. I just used these 9 volt plugs because they were quick and easy, quick and dirty kind of thing, and that's what these have on top of them. I have a adapter here so I can connect the stereo, the output of the radio directly into my camera, and we can listen to AM stereo and get a direct coupled sound sample, some quick clips of music hopefully. And here's the radio, which we're going to head out to the desert and to KYET AM stereo. We're going to get a little tour of the station by the engineer's going to give us a little tour, and he's interested in seeing this radio too, and we're going to try it out and see if it works. I don't know if the AM stereo part works. I don't have an AM stereo station here in LA to test it on. So it's all back together. I did find out that that chip right there is a like a sound chip that allows you to use these 4 pots here to control bass, treble, balance, and volume. That's why the stereo volume pot is not double. Let's head out to the Arizona desert, to Cactus Country, KYET, get a little tour of the station and see if this radio works.
KYET, Cactus Country, AM stereo 1170. Wasted days and wasted nights.
All right, we're headed out to Golden Valley, Kingman, Arizona area, and we're gonna try out our little portable demo radio, and hopefully we get to check out the Cactus Country transmitter and studio and show you the transmitting side of this AM stereo, as well as the receiver, which we covered in the first part of this video, which was kind of a discovery thing. We're going to take a look at the KYET AM 1170 stereo transmitter room here. And this is Matt. He's going to show us around. And this is his bench. He does component level repair of the station.
So here is a Motorola 1300 CQUAM exciter, which is what makes the AM stereo possible. This big honkin' switch here just decides what the meter function is. So with it in the up position, it is your normal left-right meter, but in the down position, it becomes left plus right and left minus right. So it's a matrix, which is a key part of making any stereo system work, because it has to be backwards compatible with mono. Inside, power supply card. This is the daytime equalization card for the audio sets, like your frequency levels and so forth. This card is similar to this card in that you could have these components were duplicated on this side if you had the nighttime option, because a lot of AM stations would run a separate transmitter for nighttime. So the adjustments were different because it was 2 different transmitters. Back here is phase delay adjustment. This card here, and I can take these out for you. So this is the actual CQUAM generating card. It uses, I believe it's 1596 modulator chips. So this takes left plus right, left minus right, and puts them through the mixer chips with carrier, which I believe was the crystal here. I think it's 8 times. It's either 4 or 8 times the carrier frequency. So that gets divided down and mixed in the mixers. And what's going on in this system is your left plus right information is transmitted just like it would be in an AM transmitter, but left minus right is phase modulated onto the carrier to be decoded. Also on this board is a 25 Hertz pilot tone generator, which clues in the receiver that there's stereo information present and to go look for it. And in some designs, it basically just runs the LED on the front panel.
It's got the tuning capacitor there. What's the point of that?
That
like
is
a regular AM radio.
That is actually, they did that because it's like a tunable bandpass filter. So because this is 4 capacitors in one, I believe, it's sort of ganged capacitor adjustment on this side.
Yeah, that's just a regular AM FM tuning capacitor. It looks like for a pocket radio. And all those 10-turn pots.
Yeah, very nice. What were those? Was it Bournes makes those?
Yeah. And then we have another one of those tuning capacitors.
So is what they call the sample transmitter. So this is like a little one or so watt output transmitter, but it comes out to a jack on the back to give you an example of what your signal should look like if everything's tuned right. And let's see. There's like the transformer is like the audio output to feed the normal transmitter. So they call this as an exciter, but it's more like an adapter, because it still relies on all the electronics that are in your normal AM transmitter to make it work. And then I don't remember off the top of my head what this board does. The exciter we actually have in operation doesn't have this. And this one does have the headphone amplifier, I know that.
Definitely not mass produced, huh?
No, the one that's in operation now, all the boards look like this, where it's just
yeah, you recognize that from the
yeah, it definitely
recognize
has that
that
same
from
look
this
and feel.
earlier in the video. I mean, you can definitely tell it came out of the same people. Are all the resistors in a line here too, where the bands are all on one side?
Well, I do that when I build stuff.
Yeah, but generally they don't.
Yeah, it all depends on what the mood of the guy that was actually soldering the thing together for. Because like a board this size could easily take the better part of a day to put all the components in and solder them. So here's our transmitter. It is the Harris DX10. The DX10 nameplate on this corner actually fell off while we were moving it. And we'll actually repair this a little bit later. So this, I believe the model was designed early 80s. So there's no microprocessor in here. It's all done with discrete ICs. So this is just like the control portion. This is the board that looks at everything to give you the front panel. They actually had a trademark name for it. I think it was Color Stat. So all of these are dual color LEDs. So if it's green, it's good. If it's red, you know you have a problem. And right now we have a problem because some of the cards inside have the fuses blown from all the storms we've been having lately.
Yeah, I see the wattage going up and down.
Yeah. So back behind this panel are the individual amplifier cards. So each one of these cards gives you 300 watts out, and you can imagine this running basically like a giant VU meter. So this is like your analog to digital converter card here. These ADC chips run really hot, which is why I actually have heat sinks and a fan on them. But this takes your audio input, converts it to digital information to the digital driver board, which then tells these modules to turn on and off individually in accordance with your modulation.
So it's almost like Class D audio?
Yes.
That's really how it works, huh?
Uh-huh. So because of that, very efficient.
Right, it's switching. It's 100%. There's no
92.
No, 92%.
You can't have everything. So these are all the amplifiers. So there's LEDs on here that hint you that there's a problem, whether it's a blown fuse or a FET. So we got a problem with B11B. About the They really should have put labels alongside this edge for when you got the door open, so you can actually see that that's B11B instead of having to do that. But this is what each amplifier looks like.
You said those are 300 watts?
About that.
And it's got 448 feds.
Yeah, it's IRFP 350.
Wow, I thought they would be like pill transistors.
Low frequency. We're only making a couple of megahertz tops. What's this fuse? Yeah, these are about $6 a piece.
Yeah, I was gonna say
they
those
randomly blow every time the power goes out. So that's about the only annoying part. I'm not even sure that one was good. Yep. And then, like, it's a very interesting design in the back. So there's like toroid coils that these connect to, and in the center of the toroid is like a big copper pipe, and that actually like is the output and how it combines all the modules together. And then like the number of windings on each toroid sort of differs, so there's probably some clever math that goes into that, but I don't know what it is off the top of my head.
So it's at 4 kilowatts right now?
Yeah.
40 amps.
So we'll get that to come
You
up.
can look at the SWR just by pushing a button, huh?
The coax comes out of the bottom, huh? Is that right?
It's out at the top.
It's that thing on top?
Yeah.
Okay.
So that's the SWR. It doesn't even...
Alright, so coming down here.
Get a look at this real quick.
So in the air, starting the air chain out here, we have a computer running a program called Stereo Tools, which handles our processing, and more importantly, it does NRSC pre-emphasis. So that I think started in '92 or so, but that was an attempt to make low RF or narrow RF filters sound like they were wider by pre-emphasizing or emphasizing the higher audio frequencies. But basically it's the standard nowadays.
And when you're talking about filters, you're talking about the modern AM radios with the ceramic IF filters.
Right, that are normally limited to 3 kilohertz, which is what makes them sound like telephone bandwidth.
Right, like the car we were listening to driving in here sounds like that.
We're allowed to transmit up to 10.2 kilohertz of audio bandwidth, but this program does a very, very nice job of brick wall filtering, so I have it set to 10 kilohertz on the nose. 75 to 10 kilohertz is, or 75 hertz to 10 kilohertz is our audio passband. So, God, who makes that? Alright, I forget who makes the sound card that's in there off the top of my head, but it's a very nice one with XLR output, and I think it cost us like $2,000 back in the day, and we had it lying around, so put it in the computer. So the output of that sound card comes up into our CQUAM exciter. So this is doing left and right. But anyways,
so it is in stereo and it has the pilot.
It's sending. There's controls under these panels that you can turn this and this off for like tune purposes. So up here is the modulation monitor, which decodes what's coming out of the transmitter and gives you a representation. So this is left plus right and left minus right. So for mono information, this meter barely moves. And you can also press these buttons here if you want to look at left and right, how it's decoding them. So that is a directed electronics HD radio adapter that actually gives you RCA, and it has I believe it has an FM transmitter built into it as well. But the idea was you'd buy that and you'd put it in line with your existing car stereo so you could decode HD radio. But as an unexpected side, what would it be? As an unexpected side effect, it also will decode CQUAM stereo. It just won't give you any hint that it's doing it. But when it does do it, you'll have separation, and I think it has the same problem as the Sangean receivers, as that left comes out of the right channel and right comes out of the left channel. But it does work. This is the automation controller. So this it gets the time off of the internet, and according to a scheduler, it sets the transmitter to go to low power at night and high power at dawn. And you can also call it on the phone and check in on it, change the power remotely, turn it off remotely, check the temperature remotely, so forth. One of the problems we have out here is our air conditioners only last us a year or two, which is why you saw the huge pile outside.
So it looks like we have something playing right now with more stereo separation.
Yeah. And it's like, this becomes a gray area because I don't want to get you hit with a copyright strike, but let's go find a radio. So this is the Sony SRF A100. This is basically the gold standard of AM stereo radios. I want to say it came out in the mid-80s, probably 85, 84, somewhere in there. It does a very good job. One of the big problems is it has 10 microfarad capacitors in it that leak like crazy, to the point where when you find one of these, chances are it won't work and most of the copper on the board will be etched away. So that's what this one had, but luckily I was able to see where the traces go and made it work. Yeah. If you look at the bottom here, so there is a switch that determines what stereo mode you want to be in. I think it was in, where was it? There we are. AM stereo mode A and B. So in the mid-80s, there were multiple ways you could transmit AM stereo. So what happened is in the mid-70s, I believe it was the mid-70s, and people might scream at me because I don't know my history exactly right. So what happened was the FCC said, hey, we want to transmit stereo AM, so come up with a way to do it, but you have to maintain the same bandwidth as a normal AM signal, and it has to be backwards compatible with mono. So as it turns out, there were 5 different ways to do it. So you had Motorola competing. Harris made their own system, which I actually do have the Harris Exciter, which I'll show you that here in a second. You had Bel Air, you had Magnavox, and then you had Con Hazeltine. So Bel Air, I believe, was disqualified early on because they didn't meet the required bandwidth that the FCC wanted. Then, of the 4 left, the FCC originally chose Magnavox, but then everyone else sort of screamed about it and started lawsuits. So then the FCC said, well, we're just going to let the market decide on what sounds the best. So that was why you had to make AM stereo receivers that would decode every format of AM stereo out there. Because at that point you got 4 of them. And Sony actually had a chip, or I think it was Sony. Someone had a chip that would decode all 4, and it actually had an LED to tell you which flavor it was decoding. But I'm not sure if they put that into this model of AM stereo radio or not. So then, going down the road, Harris and Motorola were so close to each other that those two merged forces. So basically, the Harris system was called VCPM for Variable Compatible Phase Modulation. And it was kind of the same thing as the Motorola system, but the pilot tone would change frequency to give a hint about what the phase angle of something was to the receiver. So when Motorola and Harris joined forces, they actually sent out conversion kits for the exciters they already had in the field to just make the pilot tone 25 Hertz and do some other mods to make it more compatible with Motorola. So then that left Motorola and Con Hazeltine as your 2 people fighting it out. So what was vastly different about the Con Hazeltine system is that AM is double sidebanded. So what Con did was he made the lower sideband left information and the upper sideband right information. So if you decoded that, or if you heard that on a mono receiver, both left and right would mix. And it also what that had going for it is you could slightly offset tune 2 receivers to get left on one and right on the other to decode it. But ultimately Motorola won because Motorola has their own chip factory. So Motorola actually created 5 or 6 different chips that are like the MC1302 series. So like 020, 21, and I think up till 28. So that's basically, I think it was 92-ish or so, where the FCC just quietly announced, okay, Motorola CQUAM is the new de facto standard.
Well, here it is, and the stereo light is not on.
Jiggle the handle.
Jiggle handle?
Yeah, try jiggling the tuning until you find it.
I did that. And maybe I'm way off. No, I'm not off. Okay, he's going to knock one of the channels out so we can see if it's actually stereo. We don't know if this radio works. I had no way to test it.
Manage his constipation with belly pain, discomfort, and bloating day after day. After realizing it with constipation or IBS-C, he found another way and finally said yes to adding Linzess.
Linzess, or linaclotide, is a prescription medicine that treats IBS-C in adults. Linzess works differently than laxatives. It lets you have more frequent and complete bowel movements and helps relieve overall abdominal symptoms, belly pain, discomfort, and bloating. These symptoms were studied in combination. Do not give Linzess to children less than 2 years old. It may harm them. Do not take Linzess if you have a bowel blockage. Get immediate help if you develop unusual or severe stomach pain, especially with bloody or black stools. The most common side effect is diarrhea, sometimes severe.
It's not stereo.
Stop taking Linzess and call your doctor right away. Other side effects include gas, stomach area pain, and swelling. There could be more to your story with IBS-C. Talk to a doctor today. Say yes to Linzess. Learn more at linzess.com or call 1-800-LINZESS.
So the stereo demodulation in this thing is not working. Well, I have a backup chip. We could try changing the chip. Well, I guess I'm going to try and change the chip here since he sent me an extra chip. Pop the back off this and try and change that. Right, I'm going to pop this chip into here. The chip has been changed. The only other thing in there is really that blue filter. I don't see how that could go bad. It's powered up.
Ceramic resonator.
Well, unfortunately the stereo demodulation in this is not working, and I did the low-hanging fruit, which was to change the chip. and it's the same thing, but we're going to do a little demonstration of AM stereo here. And what I've done is I brought a camera with a direct line input, and we're going to use his little Sony AM stereo set here, and he's going to give us a little demo, probably a bunch of 5-second song clips, and we'll let you hear what AM stereo really sounds like on a good receiver. Okay, ready? Go ahead. I want to just get a low.
Oh, I'm just trying to find something for you.
You always live your life, never thinking of the future. Life's the same, I'm moving in stereo. Life's the same, except for my shoes. Hey, mama said the way you move. A Monday warrior, mean strike. Today's Tom Sawyer, mean pride. I've got the power. Come on.
Have the hunger, we kept a lot of friends, skipped a lot of class, been on top of the world, and
190 feet tall. I think we got 1,900 some odd feet of guy wires, and no one piece is longer than 60 feet.
And the whole thing is a radiating element, right?
Yes,
Are there radials in the ground?
on the ground.
So these are the ground plane.
Uh-huh. And I built a,
And they go all the way around the outside.
yep. And I built an octagon out of copper pipe, which I think it was 8 feet in diameter. And then 4 corners of the octagon have pipes that go down into the ground 10 feet.
Here are the ground radials. So the tower height is not that critical because you're using a matching network.
Right. We can compensate for that with the tuning, but the correct electrical wavelength of our frequency would be 210 feet for a quarter wave. But if a tower is 200 feet or over 200 feet, then you have to paint and light it for the FAA for aircraft so they don't hit it. So that's why a lot of people, they'll run just under 200 feet, like say 195 or 198.
And then they electrically make it longer with the,
Right.
with the matching network.
Or you can also put a capacity tuning head at the top, which we don't have. What's at the top is a static dissipation ring.
Now, aren't the guy wires, where are they insulated?
Okay, look up. You see like these little balls every so often? Those are the insulators. So there's 24 of them total, as I recall.
So the guy wires are insulated from the radial thing. It's not,
Right.
they're not part of
Or,
it.
If you look up, you see rods right next to the towers. So those are fiberglass rods of varying length at the different heights.
Okay.
The guy points are 60, 120, and 180 feet. 20-foot sections on this tower. And then in the guy wires, it's 2,000 total feet of guy wire, but no piece is longer than 60 feet. And that's because if the guy wires were a quarter wave long, then they would start absorbing the signal and messing with the pattern and stuff like that. So each one of these anchor points goes into the ground another 8 feet. And then there's like a dead man load of concrete and rebar down in the ground with dirt and rocks buried on top of it. But the first set of these that we ordered actually disappeared from the freight company, and they pleaded ignorance. So we had to order another whole set to make this project happen. And we never did figure out where the first set went. But it's like, how do you lose a 10-foot steel rod that weighs 300 pounds? And 3 of them.
So why classic country? Why AM stereo?
We do AM stereo not because it is easy, but because it is hard. No, really what it blows down to is when I started engineering for the owner of the station, he pointed at the bottom of the rack and he said, "You know, that's the AM stereo exciter, don't you?" I'm like, "Really?" "Yes, sir." So then from that point forward, it was our mission to make this bad boy AM stereo. And it's classic country because, well, the owner likes country. And classic is fitting with AM. Otherwise, it'd be talk radio or sports or something like that.
And there's no point for that to be stereo.
Right. This here's your utility tower 340. The first 140 feet of it were built in 1977, when I understand the station was on a higher frequency. And then when it changed frequencies a little bit later, they ordered another 50 feet in 1981. So we effectively refer to it as the Brothers Tower because those are me and my brother's birthdays, and we're the ones that put it up. But all 6,000 some odd pounds of tower focus on this one point here. And that is the base insulator right above it.
So there are people that DX chase AM stations, and they mail you letters.
That's right.
And how often do you get those in the furthest away?
So if I'm lucky, I get one QSL request every 2 or 3 years.
Okay.
So it was just enough to make me print QSL cards. The furthest away that I was most impressed with was from a gentleman in Medicine Hat, Canada. And I believe that was 1,150 air miles from here.
AM FM stereo Walkman.
So this one is, I believe it's the SRF A1, so it's the same generation as the portable radio in there. This was the last that they made. So this has the AMAX logo on it. So the later Motorola chipset added some more features, particularly a noise blanker. And AMAX was also like a specification on like IF filter bandwidth. Like I think it actually specified that we wanted you to have like a 9 or a 10 kilohertz IF filter in the receiver. SRF 42.
So that's the CQUAM chip. Here, 8 volts.
Forced mono. So 9 should be high. What is this, 20 pin? Maybe you can leave it floating.
What do we think, it's pulled low?
Well, it seems low. According to this, there should be 100K going high to 8. Or maybe you can leave it floating. But that sounds awfully distorted.
Well, unfortunately, the stereo decoder on this didn't work. I changed the chip kind of out in the field. This will be video part 1. Video part 2 will include WION AM stereo radio, and also hopefully some diagnostic work in trying to get this guy to work, because that's sort of the goal of this whole project, to see this little radio reproduce AM stereo. So stay tuned for part 2. It's bound to be a really good one.